Hi everybody. Today we're going to learn how to write formulas and names for compounds that contain transition elements. If you remember, transition elements are in the 3D block of the periodic table. What that means is at least the 4s orbital has filled. And then these elements have electrons that slip under the 4s, in between the 3p and the 4s, and they form a new orbital called the 3d. If you are already lost and confused, you probably don't have to do transition elements. I usually regard that as an optional enrichment activity. So if this is losing you, hit stop, back out, go back and practice your polyatomic ions, okay? If you're like, yeah, okay, I remember that. The transition elements had a 3d and a 4d orbital. Then this video is for you. Stick around, we're going to keep going. Because they have valence electrons in the 3D underneath the 4s, they do really weird things. And sometimes some of these 3D electrons jump up into sort of like a 4s, sort of like a 4p. They do weird things. So they end up with a variable number of valence electrons, which means they can have a variable charge. So we got to learn how to work with those. This is the rare occasion where writing the formula is easier than writing the name. So let's start out with copper 1 sulfate. This copper ion has a charge of +1, but if you look underneath it, you see I have a copper ion with a charge of +2. Copper can do that. It can have a charge of +1 or +2. I have an iron of +3. Iron can also have a +2. Weird things can happen, all right? You are not expected to memorize any of these, so never stress about that. You just have to learn to work with them. So we have copper 1, I'm going to write a +1, and we have sulfate, and if you look on your polyatomic ion chart, you're going to see that sulfate has a charge, of -2. So let's write this formula. We're going to write the symbol for copper, Cu. We're going to write the symbol for sulfate, SO4, and now we balance our charges. That's not balanced the way it is. I need another copper to balance out the charges of that sulfate. We'll write down here I have copper 2 sulfate. That can happen. So again, we're going to write Cu. Again, we're going to write SO4. But in this case, this copper ion has a charge of +2. How do we know? Because of that Roman numeral. Sulfate always has a charge of -2. These two balance out. And we're done with this particular formula. All right? Let's try iron 3 chloride. We're going to write the symbol for iron. This particular iron atom has a charge of +3 because the Roman numeral says so. Chloride, remember if the ending is IDE, that is just the ion off the periodic table. So this is chlorine. You're going to look on your periodic table and see that chlorine has a charge of -1. So I'm going to write iron. I'm going to write the symbol for chlorine. My iron is a +3. My chloride is a -1. So I need 3 chlorides to balance that out. Mercury 1 oxide. Mercury is Hg. This particular mercury ion has a charge of +1. Oxide, that's just the oxygen ion. When you look it up on your periodic table, oxygen has a charge of -2. So I'm going to need 2 of the mercuries to balance out the charge of the oxygen. This is how you write a formula for a transition element, okay? The negative ion, you're already going to know. You can look it up on your periodic table if it ends in IDE. You're going to look it up on your polyatomic ion chart if it ends in 8 or 8. All right? For the transition metal, you will be given the charge in the name. That's the system we use in this class. There are other systems, but we don't use those in this class. So that's how you write the formulas. But now, let's look and see how you write the names. So, let's say that we have some formulas. And we have Mn2C not Cl, all right, that's carbon. This is going to be the negative ion of carbon. That's going to be carbide. It's rare, but it does exist. CrP, Cu2Se, TiN, and CrCl3. All right. Now I gave you a paper in your packet where it's turned landscape instead of portrait, and it walks you through all of these steps. Definitely take a look at that paper and just follow the directions at the top of each column. The first thing that you are going to do is look at your negative ion, because that's never going to change. What is the charge of your negative ion? Well, if carbon is being negative, then it's a -4. How many of those negative ions do I have? Just one. There's just one carbon. So my total negative charge is -4. My total positive charge has to equal that. My total positive charge must be +4. That +4 is spread out over 2 manganese ions. So each manganese ion must be a +2. I have +4 spread out over 2 different ions. Each ion is a +2. That's the Roman numeral that we are going to write in our name. This is manganese 2 carbide. There's a lot of manganese nodules at the bottom of the ocean, and it turns out a whole lot of them have megalodon teeth in the middle of them. So if you're interested in megalodon, check out manganese and the connection there. That has nothing to do with chemistry, it's just a neat thing. All right, this is chromium phosphide. So we're going to get our periodic table. We're going to look up the charge of phosphide. That is -3, okay? Therefore, our total positive charge must be +3. There's only one chromium ion, so it must have that entire +3 charge. This is going to be chromium 3 phosphide. Let's do this one, copper selenide. We look up selenide on our periodic table. It has a charge of -2. There's only one selenide atom, so the total negative charge is -2. That means our total positive charge must be +2. That +2 is spread out over 2 different atoms. Therefore, each ion, not atom, each ion must have a charge of only +1. So the name for this is going to be copper 1 selenide. All right, 2 more to go. We're going to look up nitride. That has a charge of -3. Therefore, the total positive charge must be +3. There's only one titanium atom to carry that +3 charge. So this must be titanium 3 nitride. Not tin. Tin would just be a lowercase n, right? One more. Chloride. Chloride has a charge of -1. There are 3 chloride ions. Therefore, our total negative charge is -3. Our total positive charge must be +3. So this must be chromium 3 chloride. Hopefully that's enough to get you started so that you can start on the worksheet that I wrote for you in the packet. Try the one that I wrote first. It's the one that's landscape instead of portrait. Try that and see if it helps you. If you try that and you're still lost, please stop where you are and come ask me in class, and I'll be happy to go over it with you. If you can work through that worksheet on your own, then go ahead and try the one in your packet that's portrait and see if you can get that one figured out. Either way, I'll see you in class soon. Bye.